This is the last of our absolute value videos where I'm going to wrap up some last minute weird stuff. Sometimes, well, actually with any math problem, I want you to learn to stop and kind of examine it before you dive in, and especially with some of these absolute value problems. Now, we've already learned that trying to get an absolute value to be equal to a negative is a complete no-no. It just won't work because by definition, an absolute value is always positive. So a positive can never equal a negative. That just doesn't work. But what about this? Here I have an absolute value being less than a negative. And if you think about it on your little number line, here's a negative. Anything from here over is a negative number. So can an absolute value be less than that? No. An absolute value will always be positive. So that's another negative idea. This is a no-no. It still won't work because this is a positive and a positive can't be less than a negative. It's just not going to work. But if I have an absolute value that is greater than a negative, if you think about it, if I came up to you and said, are all negatives greater than all positive, or sorry, all positives greater than all negatives? Well, yeah. And when you're dealing with inequalities, a lot of this comes down to what makes this true. And here, I could put anything from negative infinity to positive infinity in place of q, and that would still be true because no matter what I put in there, it'll be a positive. And any positive is going to be greater than that. So logically, that's true. You don't even have to do any algebra with it. And if you think about it this way, this would have to also be the same thing. The idea that any number that's greater than 0, well, it's a positive number. So any absolute value has to be greater than 0. So a little bit less. This one is kind of the most unusual of all of these. It's not as straightforward, and if you're going too fast, you're going to make a mistake here. So I really want you to stop and pay attention to this sort of thing. Again, I know you might be trying to get your homework done, but stop just for a second and inspect the problem. So here I have a problem that is an absolute value that is less than or equal to 0. And when you see less than or equal to, I want you to remember it's really two statements. It's saying that the absolute value of q plus 2 is less than 0, or the absolute value of q plus 4 is equal to 0. You're sort of getting 2 for 1. So in this case, we know that an absolute value can't be less than 0. So that first one isn't going to work. But we do know that it could be equal to 0. So if we set the equation up as q plus 4 equals 0, only it would be q plus 2. Sorry. It's 2 here too. If I subtracted 2 from both sides, I would have q equals negative 2. And this is the only thing that will make that statement true. So it's basically turned into an equation. And the only thing, you notice I'm using my curly brackets, that's the only thing that would work for that. So these are the last of your prep packet questions coming up. So you might want to make sure you have that ready and pause me if you need to. Couple of things to remember. No! An absolute value can't equal a negative. An absolute value can't be less than a negative. An absolute value can't be less than or equal to a negative, because basically what that is those two combined. And an absolute value can't be less than 0. All of that is all connected, that an absolute value is positive, so it can't equal a number less than 0. Now here, this again, this tells your logic that a positive is greater than a negative, that you'll be able to do something with that. And here a positive is greater than 0. You'll be able to do something with that. And here, this was the third part. It's sort of true. If it's less than or equal to 0, it'll kind of work, but you have to set it equal to 0. All right, so let's do some practicing on our prep packets. First, we'll take a look at 9A. And again, I'm just sort of modeling what it looks like to inspect. So here, this says that p plus 4 is greater than or equal to 0. And before I spend any time deciding what to do, I'm just going to look at it and go, well gosh, I could use any number if it's greater than 0. Any number will work. So before I do any partners or number lines or anything, I'm just going to tell you this. If any number will work, it'll go from negative infinity to positive infinity. And if you really wanted me to prove it, I could. So let's see. P plus 4 is flip it, 0. P plus 4 is leave it, 0. Minus 4 minus 4 is 4 minus 4. P is greater than or equal to negative 4. P is less than or equal to negative 4. And if this is negative 4 right here, this one tells me I could use any number from here to infinity, right? And this one tells me I could use any number from here, including negative 4, to infinity. So this would go from negative infinity to and including negative 4. And this one includes negative 4 and goes to positive infinity. These overlap and cancel. So that's why that works. And again, if you need to pause it and catch up, go for it. But any number will make this greater than 0. Again, it's figuring out what's going to fit in there that will make that a true statement. So here's another you try. This is B. And again, I want you to learn to inspect this. So here's an absolute value of 5n minus 7. And I know that that's positive. And here's this. Is that true? A positive number is less than negative 2? Well, no. So there's no solution. Again, this is, you're thinking of it, will it work logically? Here's 9C. Now, let's see. Oh, there's one of those pesky constants, so I have to take care of that first. So I have the absolute value of 6y minus 1 is less than or equal to 0. Now, less than or equal to 0. It can't be less than 0, so can it be equal to 0? Yes. So if I say 6y minus 1 equals 0, add 1 to both sides, divide by 6. If and only if y equals 1/6, will that be true? Any other number, it just won't work. So this would be, and there you go. And that should be the end of the absolute value videos. Thanks for watching.